This is our chapter number 6, devices and IO management. Okay, what is the core problem, right? So the problem is that CPU is fast, but devices like disk, keyboards, network card, GPUs, and USB devices are slow and operate differently, right? There are different kind of operations and operating methods, right? And actually CPU is fast, but all these are slow, right? The OS need mechanism to communicate with them efficiently without wasting CPU time. As we know that CPU time is a very important resource, right? It's just like the heartbeat or the oxygen of our system, right? So here the whole thing is going to be focused on saving CPU time, right? There, without it, lot of CPU time will waste, right? So today we're going to tackle that problem or that particular thing in this chapter, right? So here is a note that all the commands are written in bash so that you use at the particular or the appropriate step. Okay. So now the first part of our chapter is device drivers. So what's the problem actually is, right? So problem is every hardware devices has different registers, protocols, behaviors, and the OS cannot directly handle every device in a single specific way, right? In a single specific device. Okay. Firstly, I wanted to know what is registers here. Unique. We have already studied that, right? Are you writing right now? Please try to answer it. Maybe the broken one, right? And fast. Okay, just tell me one thing, right? A register or memory, I forgot. Okay, just one another question, right? Either registers are memory or the storage device like SSD or HDD. It's memory. Register is the smallest memory inside the CPU. If you got remember when we read and study about CPU architecture, there we have discussed about that, right? Registers are the smallest memory which is placed inside the CPU so that it can power up or boost up the CPU to handling the tasks, right? Okay, so every hardware device have different registers, protocols, and behaviors. The operating system cannot directly handle every device in a device specific way. Okay, so what's the solution here? The solution is device driver, software that provide an interface between operating system and a specific hardware device, right? Means actually operating system need something to interact or communicate with the hardware device, right? So but without device drivers, it is impossible for it to communicate with the hardware, right? So what device driver actually does here, it create a layer, or you can say it create a software, it is a software, right? Which used to provide interface for our operating system, or a way for our operating system to communicate with the specific hardware device, right? So here is the flow, that how the flow works here. Firstly, when the task was executed at the application level, means triggered at the application level, system calls takes us to the OS or the kernel, right? Then after kernel, there will the device drivers will come here, right? And after device drivers, the signal or the particular command or the action will be transferred to the hardware, right? After kernel passes it, then the device driver comes into the role here, and then device driver, it will simply move to hardware devices. Okay, so what a driver does, actually what's the working of the driver, the device drivers, right? So it initializes the devices, send commands to hardware, read device status, handle device specific operations, handle device interrupts, and exposes exposes a standard interface to the user. Means actually all the maintenance and the connection which the OS need to establish between the operating system and the specific hardware, it is provided by the device drivers. Okay, so just like as in Python we need compilers, right? Uh, or to compile our language, means not sorry, we need interpreters, right? Just like that. Uh, for example, yes, machine cannot understand our direct written code in C, so it will convert it into the binary one, right? And the specific layer which works there to convert it into the binary, that is means that's not the driver, right? That's the layer which helps to communicate between the two parts. Same like that here. The drivers are the one which helps to communicate between the operating system and the hardware. Okay, here is an example what happens when we execute cat file.txt. What is cat? Unique. No, the first. It's the older message. You didn't write. You are right, but actually cat is the tool which is used to read file, not write, right? Cat is the tool which is used to read file at the bash language. Right? Means at the shell, not bash language, at the shell, right? Cat is the tool or the utility. Just like our applications, right? We have notepad just like that. Here it is cat, which is used to uh, dump or see the content inside a file. Okay, so when we execute file.cat file.txt, the application doesn't need to know how your SSD work. Okay, the cat will transfer the read command here, right? Read system call, right? And this read system call got execute at the file system storage driver, and then it will move to storage controller and then SSD, right? We need not to remember this flow, but we actually need to understand that how the things actually work, right? The more you are interacting with the flows or the command flows, the better your understanding will be that okay, how the thing can actually work at the particular if at the particular place you forgotten something about, right? So okay, when we execute cat, it will move from cat to read system calls. What is system calls? Unique. What is system calls? You know, forget. If you know, try to answer it, right? To give command. No. System calls are actually just like the delivery boy between your user space and the kernel space. We have discussed is it in our earlier module, right? The computer architecture, no, or the computer architecture, or this out of this both module, right? I don't remember that in which one, but we have already discussed about the kernel space versus the user space, right? Maybe it is an operating system, right? So there are two you can say that there are two specific areas or the divided areas in our system, right? One is what I should say, yes, one is the user space and the another one is the kernel space. So and they both are matlab, means fully disconnected to each other, right? They cannot interact between each other. So system calls play the role there to pass out the commands or the actions between them, right? It is just like delivery boy between user space versus kernel space. Did you got it? You don't. Okay. Did you remember what is user space and kernel space? We have already studied about that, right? What is user space and kernel space? That's why I'm talking again and again to revise the particular thing, right? And the notes. Okay, you don't know what is user and kernel space. I think you should revise the class, right? I will tell you about which class, because after that class you will understand that what maybe you haven't revised. That's why you forget about that. Shell, system libraries, device kernel. You have to check which one, bro. Okay, I will message you. I think it's our system communication. Okay, it's system communication here. Latency throughput, program run. Maybe it is in our chapter number one or either chapter number two of operating system, right? Yes, maybe it is in. Most probably it is in our chapter number two, right, of operating system. You should refer to that. Then you will understand that what user space versus kernel spaces and also the system calls we have already discussed there. Okay, let's move, because if we stuck on that particular topic then we will waste a lot of time here. Okay, so the application doesn't need to know how your SSD works, right? Firstly, the command or the execution will flow through cat, and then here it triggers the read system call applied on file system, storage driver, then storage controller, and then SSD. Okay, did you got it that what drivers is device drivers is or not? Because for right now it's important to understand this particular thing. Or have any doubt in this? Okay, you have doubt. Okay, so simply device drivers are the one, or it is just a layer or a communication layer between operating system and your hardware, right? It is the layer which you use to communicate or set up the communication between operating system and your hardware, because operating system cannot directly interact with the hardware devices, right? Have any doubt in this? Okay, it's nothing more than that, right? It's the simplest way to understand. Okay, now here are few practical show device files and show kernel device classes. Let's take a look on it. Where it is. My machine is off. Just wait for a minute. Let's tips. Need to step. Unique, is my voice clear to you? Unique, is my voice clear? I've been disconnected due to network issue. Okay. Is the screen visible and my voice is clear? Okay. I have to restart new machine. Mhm. Mhm. Okay, can you say that means sorry until the machine starts? Give me an answer of this question that where it is. Yes, here it is. What is slash here? What does the slash describes here? Unique. We have studied this in our earlier classes. Past. What is this slash defines here? Did you remember it? It is the storage, right? The root directory means not root directory. It is the head directory of our whole system, right? And inside that, if you remember about the file system, right? Inside this slash directory, there are multiple subdirectories and then subdirectories in that as well, right? You need to revise, right? Because if you don't revise, you will forget that whatever you have learned about in the earlier classes. Okay, ls slash deps. Am I right? Command, I don't know. Yeah. So these are all the devices files, right? We need not to go into depth of this, right? It's just okay. Let's take a look on. There is NVRAM and port. Okay, just take this take the shot of this command, right? That you can list the devices, right? Or devices files using ls slash dev. Whenever we need some work, then we will refer to this one. Okay. Also, there is one more command, show kernel devices classes. It's not in use right now, but I just show you the demo that what it will look like once you run it. This much. When okay, yeah, we are not going in depth of this because if we go, then we lost a lot of time. Okay, tell me, does this topic, the device driver, is clear to you or not? Right? Is it clear? Yeah. And keep this sequence into your memory, right? That when the uh, uh, instruction flow through kernel, then it will move to device driver, and then it will go to hardware device, right? Okay. So second we have interrupts. What are interrupts? Unique. What are interrupts? You know it. Right? You know this topic. I know that. We have discussed this. You forget again. Okay. Make sure to revise. Okay. And did you prepare notes about this? All the classes which we are covering right now, right? All the topics. Are you creating notes or not? Did you have your personal notes instead of the GitHub one? Yes. No, you should. That's the problem why you are lagging at all these things, right? Once you will create that particular notes, you will actually able to recognize and retain it inside your mind. Okay, so interrupts. Whenever the device, okay, okay. And the problem is that a device may take millisecond to complete to stop current program what is running. It not particularly inter sorry, it just interrupt, right? Don't stop what you are saying. Yes, it don't stop, it just interrupt between the process to know the CPU that okay, there is one more thing outside there which is waiting for you. Whenever any device um, give any signals, right? Okay, so a device may take a millisecond, although you are right, right? So a device may take millisecond to complete an operation if the CPU continuously check whether the device is finished. CPU time is wasted. Means it just it can't be bind or stay towards a single position, right, or the single device. Uh, Here it is written that okay, CPU keep asking, is your work done? Device say no. Then is your work done? Device say no. Then it say yes. So means it's just a wasting of CPU time. In maybe in whole this chapter we just try to prevent the wastage of our CPU time, right? Because only CPU time is the one which you can say which describes the whole performance of your device, right? What is the solution, right? Means we have to basically interrupt the process, right? Or know the CPU that okay, there is someone else as well. CPU starts the operation and continues doing other thing. Here, CPU starts the operation and continues doing other things as well. So, when the device finishes its work, right? Finishes means finishes its work. The thing will flow means it's just the flow from device to interrupt to CPU to interrupt handler, and then the process continue, right? Not need to take too much stress about all these things, right? These are just the basic things which you need to know. Yeah, you need not to go in the depth of this until you are not working on the specific projects or topic like that. Okay, once you will go, then you have to go through with these all. So here is example: pressing a keyboard key. Whenever you press a key pressed keyboard controller, right, the signal flow to the keyboard controller, then the hardware interrupt. The hardware means our motherboard, right? Then it moves to CPU, keyboard driver, operating system, and application, right? So here is the important terms, right? So where is interrupt? Oh, where it is? I think we have forgot something, right? Interrupt request and no. Yes, we have forget something. Okay, I will continue in the remaining part in the next class, right? In our upcoming class. Just keep this term and these terminologies into your mind. IRQ refers to interrupt request and ISR refers to interrupt service routine. And interrupt handler means the kernel code that handles the interrupt. Maybe the generation means the code which is or the program which is responsible for the generation and the whole working of the interrupts, right? It is controlled by the interrupt handler. Here is one experiment: show interrupt counts for device. Okay, let's start run. I also haven't run this command. Cat proc interrupts. Okay, Unique, tell me a thing here. Right. What is proc? What is interrupt? And what is this slash? I think you should open your mic, right? Because if you write this all, then you will take a lot of time. Open your mic and answer these things that what is proc, slash, and interrupt. I'm not talking about this slash, I'm talking about this slash. Please. What is proc here? Okay, I will give you options as well. Either proc is directory or a file, or interrupt is directory or a file. You just have to define their type, what they actually are. Are you able to recognize them or not? Why interrupt is file? Means how do you recognize that? Okay, interrupt is file on what basis? Huh. So maybe there might be one more as dot txt, isn't it? It also can be, no? Take a look here. What is this? Cat, right? This cat. Okay, I think it's going to. It's purely over from your mind. Neo, bro, you are too late today. Too late. I have to open this. Okay. So, firstly, Linik, is it clear till here, right? Interrupts. We have already covered this. I don't think so that we need to go through it again. Linik, is it clear? Yeah, bro, Neo, just wait for it. Make show me thumbs up either. Okay. So, bro, you have to we are continuing from our section 3, right? And maybe you have to take a reference from our YouTube channel about the parts which you have missed. Okay, I have to keep open this because you always use write out the message. Okay, so here our third section is DMA, direct memory access. So what is it? Firstly, the problem: moving large amount of data through the CPU is inefficient because again it will also take the CPU time, the resources which shouldn't be utilized at that time, right? We are always searching for the efficiency, right? And if the whole large amount of data will flow from CPU, then it will make our machine or make our CPU inefficient, right? Because most of the time it will busy into this just moving the amount of data, right? Without DMA, what if there is no DMA? Device CPU RAM. Did you got it is the amount of data which is flow, right? From device to CPU to RAM. The CPU must participate heavily in every transfer if there is no DMU. Sorry, DMA, direct memory access, right? What is it? A DMA controller allows a device to transfer moving data directly to or from RAM. Instead of interrupting with the, or instead of putting RAM between the cycle, the DMA actually takes all of the data, right? Which needs to be transferred from multiple locations. Means it's just act like here, for example, let's take a look. There is a teacher in your school, right? Your class teacher. If principal come and say that okay, this is the particular notice which you have to transfer to all of the students. If principal itself give that particular notice to each and every student separately, right? Then it actually wastes a lot of important time of the principal. So what the principal does, it will transfer to the class teacher. Then the class teacher redistribute it into all between all the students, right, in the class. Same like here, as in the school there is the role of principal, here it is CPU, and just like a class teacher who used to just take out that particular notes or the material whatever it is, and it will transfer to at the every location where it is needed, right? So yeah, uh, did you got it, new and unique, that what DM actually is, or I have to resolve it in a much more easier language? Okay, Neo, did you got it? Okay. The CPU mainly configures the DMA transfer, start it, does other work, and receives an interrupt when finished. So Actually, here means it's just like DMA creates the another space where the whole data will store, right? What CPU does? CPU just access that or configure that DMA transfer. Whatever the data returns here or whatever the work it returns here, right? It starts that data, the work will done, and once the work was finished, then CPU will receive the interrupt, right? So here is an example reading a large file. The flow is just like that. Firstly, the data flow from SSD to DMA, then from DMA to RAM, and if it is further needed, then CPU process the data, right? This is the whole cycle of the flow of the data, right? It's don't directly get to the particular either RAM or CPU. It will go to DMA, which is direct memory access. Okay, it's just easy to remember. Direct memory access means you can directly access the data from this memory, right? DMA. Okay, there is one experiment. So DMA channels were applicable. uh, this we just need to understand that what this command wanted to say. Otherwise, we need not to go in depth with that. What is it? Proc and DMA. Proc is basically a directory which used to contain all the information about the processes, right? It is cascade slash. Okay, just move from it for right now. Don't focus on it. Okay. The main thing is that you will understand the role and the function of DMA, right? Did you got it? Unique and neo. Okay. Now our fourth concept is about buffering. What is buffering actually is? Neo, did you know what is buffering is? What buffering is? Okay, you don't know. No matter. Let's study that. Okay. So here is the problem. Producer and the consumer may operate at different speed. It's normal thing, right? If you are the one who at the server and I am at the receiver end, right? Then might be that you operate with different speed and I operate with different speed, right? And it's normal, right? We can't maintain the speed at that much big area, right? So producer and the consumer may operate at different speed. Example, here it is. I just give the example of the real world, but means in a much broader area. But here it is just defined about our machine or the OS, right? So, for example, keyboard is slow because it is typed by us, right? We have to give the input to keyboard, and CPU is extremely fast, right? And at the time it was not it was not that fast, but as our technology evolves, it is. So keyboard is slow, CPU is fast. Both the producer and the consumer run here at different speed. Okay, so if CPU has to process every character immediately, synchronization would become inefficient. And it's normal, right? We need to maintain the speed to synchronize in the best possible way we can. So what's the solution here? The solution is buffer. What buffer is? A buffer is a temporary memory used to hold data while it waits to be processed or transferred. If you take a look, then there are multiple kinds of memory which we have discussed till right now. Make sure to keep remember the notes so that you can distinguish between the different memories, right? So yes, a buffer is a temporary memory used to hold data while it waits to processed or transferred, right? I don't think so that I need to describe this line in a much simpler way because it is already simple. So the data will flow from producer and it will buffer inside the system or the OS, and then it will move to consumer when its turn comes to be processed, right? For example, when you type hello, it moves to keyboard buffer, and after that it will move to terminal, right? The action which I perform here of selecting this particular text, it firstly move to buffer, and after that buffer it will uh, show on our screen, right? The character can wait in the buffer until the application reads them, right? It is the normal which we have already understand about. Why buffer matters? Because it handles speed mismatch, allows batching, smooth burst of data. Means smooth burst means just a smooth flow of data, right? By also maintaining the speed and reduce unnecessary device operations. Okay, did you got the meaning of buffer? It's just a where it is. Yeah, it's just a temporary memory, right? Temporary memory which is used to hold the data which while it is wait or processed or transferred, right? Did you got buffer? What buffer is? Now we are moving to caching. We have already studied about cache, right? Meaning how much type of caches are there? Did you know it or forget? Just answer fast. If you forget, then thumbs down first. You forget. Neo, did you remember how many type of caches are there in our system at a particular inside the CPU? We have discussed about L1, L3, and L1, L2, and L3, L3 cache, right? Keep remembering the notes, bro. Otherwise, you will forget everything. Okay. Here is caching. Sorry. Some data is accessed repeatedly, but the underlying device is slow. For example, maybe I need few amounts of bits or the code again and again and again, right? So if we access that particular thing again and again from the server, right? For example, uh, Unique is an Instagram nerd, right? She's an Instagram nerd. She always just wait for a minute, then go for Instagram, scroll up for 30 minutes, then when his mom shout on her, then it down the phone, and again after 5 minutes it will start. So what if she actually access the server of the Instagram through his phone, means through the on the user side, right, at the user side, again and again repeatedly. So it actually access data again and again and again, right? It's the request which is generated from his phone to the server ends, right? So it needs to transfer a very much distance, right? Or uh, utilize the resources. Make sure the cache which I have just now tell about the L1, L3, L2 cache, right? That cache are different, and this caching is different. Both are different. This is on the software side or our operating side, operating system side, and that caching was our storage, right? Both are different. Don't try to just mismatch them. Okay, so some data needs to be accessed repeatedly, but the underlying device is slow. To handle that problem, here is example that RAM is fast, SSD is slow, HDD is much slower, right? So repeatedly reading the same amount of data from the storage wastes time because your system is slow. So here the solution, which is cache, keep frequent recently accessed data in a faster storage layer. For example, here, yes, we have here when we access application, it generates a cache, and then after cache there are two other points, right, which is cache hit and cache miss. Here it is about, right, that what cache hit actually is. It is requested data exists in cache, which is fast, and cache data isn't cached, right? Means if you access the memory first time, then it is cache miss, right? Because the data is not already at your cache, right? It's not already stored at your cache. But once you access the data repeatedly, then it will on cache hit, right? Did you got both of these things, right? Cache hit and cache miss. Unique, you don't know. Means you don't got it. Yeah, Neo got it. So unique, whenever we need to, let's take an example, right? I start my Chrome. Here it is. Which ID? Load. Okay. If okay. I need to stop. Okay. Just understand. Maybe you have take a look on whenever we start a new app. I don't know why these social media. Okay. So whenever you search something for first time at your phone, right? You will notice that it will take a longer time as compared to usual, right? When it's first time. But whenever you uh, access that particular site or that particular amount of data another time, it will load fast. And at our storage as well, you can find out the cache option, right? You can do an you can do an experiment, right? Go to your setting of your phone, right? And at that place, go in YouTube, delete the history, right? Only cache, right? Nothing else. Inside the settings, go to the storage and find out the apps, YouTube, and delete the cache from there. Once you delete that cache, then you should open the YouTube. You will find that it takes much more time as compared to it normally used to take, right? And once you have accessed your YouTube, then you should back it again, start. It will take much less amount of time as compared to the earlier one, right? I can't show this on my laptop, right? But you can use this experiment, right? It will show that okay, what cache actually is. So cache, it just take a copy of the particular data or the particular access site information, anything which you have accessed first time, and then it just stored in a, you can say that it's stored in a temporary memory, right? Not temporary, just like here buffering, it is same like that, but buffering is for temporary, cache is on your particular application for a long time, right? Is it clear right now? Or if it not, then please tell me. I will try to, you know, if you have doubt, flag it, right? I don't think so that you got it till right now. Really. You already know that, bro. I know that. Okay, if you have any doubt, you will ask me after class, right? There are two things, cache hit, cache miss. These are not that much important, but I'll add it. Okay. So there are few experiment. Check cache or memory information. Free hyphen h. We have already learned this a lot of time. Free hyphen h. It gives us the information about the storage of memory, right? This one which I wanted to run right now. Check file system and the storage cache effects. It's too long. Firstly, we need to synchronize. Copy it. Come here. Paste. I think I should use. No, no, no. I think they both are the single command. Actually, I also haven't run this command till right now. Okay, okay, okay. Mhm. I don't know why it isn't running right now. These both are on phone. Okay, I will firstly troubleshoot this problem that what I am actually facing. it actually saves it into echo 3. Okay, we will tackle this another time when we go through it. Okay, just keep it into a side for right now. So note that do not run the. Oh, sorry, I have run it. Do not. I actually think about that, right? And I know that there is a one command which I don't have to run. No, no problem. I have to. Maybe I have to leave that particular machine. Okay. Do not run the second command. This one on the production system because it clear cache and it mainly useful for controlled experiment, right? It will clear the kernel's cache. Very bad, no problem. Okay, so cache is our last topic of this device and IO management. Then there is just a summary of the whole class, right? 5 mechanisms to solve 5 different problems. Device driver, different hardware interfaces, right, to connect between different hardware interfaces and uh, to provide the layer of communication between the operating system and the hardware. So standard OS can communicate between hardware interfaces. Okay, then we have interrupt, CPU wasting time pulling. So time pulling, not pulling, polling, and then device notifies CPU. There is DMA, which uh, which tackles the problem which is CPU wasting time. CPU wastes time moving data, right? In moving data. So what it does, it uh, used to set up the communication and the transfer between device and the RAM, right? The transfer of data. There is then buffering, which producer to match out or to synchronize between the consumer and the producer. The buffer uh, is a temporary data, right? Which is or temporary storage, right? Which play a role here to synchronize between the consumer and the producer. And then we have cache, repeated slow. Just wait for a minute. Okay. So cache, repeated slow access, right? Because if we need a particular amount of information again and again and again, then it will actually slow down the speed. So what it does, it keep frequently use data nearby, right? So that it will help you to access it fast. Okay, this it's a mental model you can remember. Okay, so Unique and Neo, have you any doubt? Neo, this is the whole summary of our today's session, right? We have discussed about 5 mechanisms or what I am doing right now. Okay, it is, yeah, it is the 5 different mechanisms which are used to tackle out 5 different problems, and these are the solutions which they actually provide. Okay, Unique and Neo, have any doubt? No. Neo, yeah, thank you very much. Okay, so can we wrap it up? Neo, make sure to take the reference from the YouTube class, right? It will upload or live at the YouTube uh, at something around 12 p.m. tomorrow, right? And yes, and guys, please keep remember revising the notes, right? If you don't revise the notes, you will have to tackle a very big problem, right? You will have to face it, not tackle. You have to face very big problem because आगे part teaches apart, right? Hope you have listened about that. Okay, so let's wrap it up for today. Meet you at the same time, 3 p.m. tomorrow, right? So can we wrap it up, guys? Okay.